So welcome back, and today we'll see the other form of Fourier series, that is Fourier series written in terms of exponential functions. So last time we have seen series in terms of trigonometric functions. So that is why we have written the Fourier series as a sum of sinusoidal functions and cosine functions along with a DC term. Okay, so we are starting with, just recall the last series, that is f of t is equal to a naught plus summation from n is equal to 1 to infinity a n cosine n omega naught t plus b n sine n omega naught t, and very simple substitution. So you can actually write what is cos theta. Cos theta is nothing but e raised to j theta plus e raised to minus j theta by 2. So here instead of theta we have omega t. So we can write it as e raised to j n omega naught t plus e raised to minus j n omega naught t divided by 2. And instead of sine term, what is sine theta? Sine theta is nothing but e raised to j theta minus e raised to minus j theta by 2j. So instead of that, you can substitute, instead of theta, you can substitute n omega naught t. So you can get that term. Okay. Then you open the brackets, everything, and collect the terms of e raised to j n omega naught t. Okay. Collect the terms of e raised to j n omega naught t. And you can see that the term after that, what is inside is an minus j bn by 2. And similarly, you collect the terms of e raised to minus jn omega naught t. What is inside, what you get is an plus j bn by 2. So you get two complex numbers. Okay, so a naught, you'll very shortly you'll see what is a naught. A naught is nothing but c naught itself. Errol also have made such a statement. Okay, so a naught is nothing but c naught, but I'll explain why it is a naught is equal to c naught. So I simply replace a naught by c naught. Then a summation from n is equal to 1 to infinity. I told that this is a complex number. So an minus j bn by 2, I represent it as cn bar. Bar in the sense it's a complex number. Just to represent that cn represents a complex number, you have to put a bar over that. So that is cn bar e raised to j n omega naught t plus summation n is equal to 1 to infinity. Now, if cn bar was an minus j bn by 2, then its conjugate is an plus j bn by 2. So that conjugate is represented by cn bar star. So cn bar star is nothing but the conjugate of cn bar, which is an plus j bn by 2. So cn bar star e raised to minus jn omega naught t. Now let us define cn bar star. Let us define that as cn minus. So earlier you had cn dash. Now you represent its conjugate cn bar star as c minus n dash. C minus n dash. Instead of cn dash, you have c minus n dash for its conjugate. Okay. Then you write the equation by substituting, replacing cn bar star with c minus n star. Okay. Now, you replace the dummy variable. You replace minus n by a dummy variable n. That is, replace minus n by n. Replace minus n by n in the last term. Replace minus n by n the last term. Okay. That is, we are replacing minus n by a dummy variable n. Okay. What you get is c naught will remain the same. The second term, that is summation from n is equal to 1 to infinity cn bar e raised to jn omega naught t. That also will remain the same. But the summation where n is equal to 1 will become from n is equal to minus 1 to minus infinity. Okay, that is, we are replacing minus n by n. So obviously that becomes minus 1 to minus infinity. And then c minus n bar becomes c n bar. Okay, because since we are replacing minus n by n, then e raised to minus jn omega naught t becomes e raised to plus jn omega naught t. Okay, this is a change. Okay, now you can bring everything as a single summation. See, I can make a continuous summation from minus infinity to infinity. Why? That is, I already have summation from n is equal to 1 to infinity. I have summation from minus 1 to minus infinity. Okay, and the remaining term was for n is equal to 0. So n is equal to 0 is nothing but z naught. So everything is covered. That is why I can make a continuous summation from minus infinity to infinity. So f of t is equal to summation minus infinity to infinity Cn bar e raised to jn omega naught t, where Cn C minus n dash or C minus n bar is equal to Cn bar star, that is a conjugate of Cn bar. Okay, so you can see that what I have shown in that box is nothing but the exponential Fourier series. So you can see that it is a very compact way of representing Fourier series, very compact way of representing Fourier series. Okay, so so instead of, there is no need to grapple with a naught, a and b and everything. Instead you have to find only one term, that is Cn bar, instead of going and finding a naught, an and bn. So it's very easy to write a Fourier series representation in the form of exponential series. Okay, now we have already described Cn bar as a naught, sorry, an minus jbn by 2. Okay, that is Cn is equal to an minus jbn by 2, and therefore magnitude, complex number has a magnitude and phase. So what is a magnitude? Magnitude is root of an square plus bn square, the whole divided by 2. 2, the magnitude is the same, but the complex number has a magnitude an square plus bn square. Okay, magnitude of 2 is the same. Okay, so you can write 2n bar is equal to root of an square plus bn square. I had made a statement earlier when I described the Fourier series in sine functions. We have represented root of an square plus bn square as 2 Cn bar, and I told then that I'll describe that in a little bit later, but this is the reason, that is 2 Cn bar is equal to root of an square plus bn square. Okay, now I just want to find, anyway I have to evaluate Cn bar. Okay, only I have to evaluate Cn bar, but I should get an equation for finding, for evaluating Cn bar. So next procedure is to evaluate what is Cn bar. So for that we have Cn bar is equal to an minus jbn by 2, and already we, from the first series, we know what is an is nothing but 2 by t naught, integration from 0 to t naught f of t cos n omega naught t dt, and b naught we know, that is 2 by t naught, integration from 0 to t naught f of t sine n omega naught t dt. Okay, and you substitute that for an and bn, and outside you have minus 1 by 2. Okay, very simple. Okay, from that f of t you can take as common, dt also you can take as common, integration is same, so integration also you can take common, that is from 0 to t naught. What will be inside the bracket will be cos n omega naught t minus j sine n omega naught t. Okay, now cos theta minus j theta is nothing but e raised to minus j theta. So you can replace Cn bar as Cn bar is equal to 1 by t naught, integration from 0 to t naught, f of t will remain the same. What is inside the bracket will be e raised to minus j, instead of theta we have n omega naught t dt, or Cn bar is equal to 1 by t naught, 0 to integration from 0 to t naught f of t e raised to minus jn omega naught t dt. So this is the equation which you have to use for the evaluation of Cn bar. Okay, and and how to get the value for C naught? I told that earlier that I made a statement that A naught is equal to C naught. Okay, or A naught was simply replaced by C naught. How that is occurring? Okay, so we know the equation for Cn bar. If I substitute for n as 0, if n is equal to 0, then e raised to 0 is 1. So what is happening? If n is equal to 0, then Cn bar is equal to C naught, that is equal to 1 by t naught, integration from 0 to t naught f of t dt. And this was the same equation for A naught also. A naught was 1 by t naught, integration from 0 to t naught f of t dt. And this is the equation you have to use for finding C naught. So what is C naught? C naught is nothing but 1 by t naught, integration from 0 to t naught f of t dt. And that is why A naught was simply replaced by C naught. And in problems also, whenever you have to calculate the value of C naught, you have to use this equation and not the equation of Cn bar. Okay. Okay, so C naught is equal to 1 by t naught, integration from 0 to t naught f of t dt. Okay. Now, one thing, this is actually a thing that is individually, that is from the Fourier series. From the Fourier series, f of t is equal to summation from minus infinity to infinity Cn bar e raised to j and omega naught t. That is, Cn bar e raised to j and omega naught t is not a physical signal, because that's an imaginary term is attached to it. That's not a physical signal. Okay, but you can combine two such signals and make the signals physical or real. Okay, how can you do that? That is, you simply add c minus n bar e raised to minus j n omega naught t with cn bar e raised to j n omega naught t. Okay, now you can replace or combine and write it as 2 cn cos n omega naught t plus phi n. Okay, that is very easy to find out. Okay, so cos signal is a physically realizable signal. Okay, and that is why the magnitude of nth harmonic signal is 2 cn. If I want to find the magnitude of the second harmonic, okay, that is equal to 2 into c2. Okay, if I want to find the magnitude of third harmonics, that is equal to 2 into c3. Okay, so in general, the magnitude of that signal is having a magnitude per cosine magnitude is 1. So that signal, that value will have a magnitude of 2 cn. So in general, the magnitude of nth harmonic is 2 cn. Okay, now a very important example. See, I have given a material that is regarding problems after the half-wave symmetry video, where I have dealt with 2-3 problems. In that, you have to I hope you have done example 4.7 in that material. Okay, and that same problem is taken here also. I'll be using the exponential series to solve. Okay, and after all, we'll just compare the results that you got in that example 4.7 with the example with the result of this problem. Okay, so there also it was a square wave of amplitude a, and the negative cycle having a magnitude minus a. Time period is t naught. Okay, and it's a periodic signal, but it's not a sinusoidal waveform. And like I explained, there is only one term that we have to find, that is cn bar. And from equation we know what is cn bar. Cn bar is equal to 1 by t naught 0 to t naught f of t e raised to minus j and omega naught t dt. Okay, so I can split this integration into two, because we are having two different values in two half periods. So first integration is from 0 to t naught by 2, and in that, instead of f of t, we can simply substitute the magnitude a. So a, what is remaining is e raised to minus j n omega naught t dt, and the next integration is from t naught by 2 to t naught, and there you have the value in that half cycle as minus a. So minus a e raised to minus j n omega naught t dt. Okay, now I can just integrate a. I can take common. Okay, so that minus can also be outside, and if I perform the integration, e raised to the result is e raised to, I am integrating with respect to t. So what is accompanying other than t will be coming as the denominator also. Okay, so it becomes e raised to minus j n omega naught t divided by minus j n omega within limits 0 to t naught by 2, minus, this minus is nothing but of minus a we have taken outside, that minus sign will be coming in between. And similarly, integration of that e raised to minus term is minus j n omega naught t is nothing but e raised to minus j n omega naught t divided by minus j n omega naught within limits t naught by 2 to t naught. Okay, and 2-3 things, that is we have to apply lower limit and upper limit and lower limit. So after application of so we have to see what is coming when we apply the upper limit and lower limit. So if you concentrate the first term, you have to apply the upper limit of t naught by 2. So we'll just see what is the result. That is what is e raised to minus j n omega naught. Instead of small t, if I substitute t naught by 2, you just see the naught I have written there. That is, instead of t, I substitute t naught by 2. So we know what is omega. Omega naught is nothing but 2 pi by t naught, and t naught by 2 remain, and that t naught and t naught gets cancelled, 2 and 2 gets cancelled, and what we get is e raised to minus j n pi. So e raised to minus j n omega naught t naught by 2 is simply e raised to minus j n pi. Okay, now what is e raised to minus j n pi? we know that e raised to minus j theta is cos theta minus j sin theta. So that means it is cos n pi minus j sin n pi. Okay, so sine 180, multiples of 180 degree, that is sine pi, sine 2 pi, sine 3 pi, sine 4 pi, sine 0, everything is 0. So the imagine that term, the sine term disappears. What is remaining is cos n pi. Cos n pi. Okay, now next term is that is if t is replaced by 0, if t is replaced by 0, then any term raised to 0 is 1. So e raised to term 0 is equal to 1. And next, already then t naught by 2, if you substitute instead of t small t naught by 2, we have already evaluated. Next, if you substitute instead of small t, t naught, that is e raised to minus jn omega naught. T naught is nothing but e raised to minus jn. Instead of omega naught, I can substitute 2 pi by t naught multiplied by t naught. That is equal to t naught and t naught gets cancelled. What you get is e raised to minus jn 2 pi. Similarly, you can see that sine terms are disappearing. That is equal to 0. What is remaining is cos 2 pi n. Cos 2 pi means it is actually 0. So multiples of 0 is also 0. So cos 0, we know it is 1. So e raised to minus jn 2 pi is nothing but 1. Okay, so keeping this in mind, you substitute the value. So upper limit, when you apply t for t naught by 2, it becomes e raised to minus jn pi, then minus, then e raised to 0 is 1, so minus 1, upper limit minus lower limit, that is the case. And outside you have a minus. So if you apply things inside, that will be e raised to so e raised to minus jn omega naught t naught is nothing but, we have already described, that is equal to 1. Okay, so that is 1 here. And if you take the minus sign also inside, that becomes minus 1. And again you have minus of minus plus. Then if you apply t naught by 2, that is also e raised to minus jn pi. Okay, so if you combine, that is, it becomes 2 e raised to minus jn pi minus 2. I can take 2 outside, so that becomes 2a by minus jn omega naught t by omega naught t naught. What is inside the bracket is e raised to minus jn pi minus 1. Okay, so again we have to test two conditions, that is, what is the value for this Cn bar for n is even, and what is the case when n is odd. Okay, so when n is even, that is e raised to minus n is even means e raised to 2 pi. 2 is for example, if n is 2, 4, etc., 6, etc., that is e raised to 2 pi. 2 pi is equivalent to 0. Okay, 360 degree is equal to 0 degree. So that means cos 0 minus sine 0. Cos 0 minus sine 0. Sine 0 is already 0. Cos 0 is 1. So result is 1. 1 minus 1, it is 0. So for even terms, the whole Cn bar becomes 0. That means all even order harmonics are absent. Okay, now what if the case of n is odd? So when you substitute n as odd, that is pi, n is equal to, when you substitute n is equal to 1, that becomes e raised to minus pi minus j pi. Then n is equal to 3, it becomes minus j3 pi. Likewise, n is equal to 5, it becomes n e raised to minus j5 pi. So multiples of pi means that is odd multiples of pi means it is minus 1. That is, if it is pi, that becomes cos pi minus j sin pi. Sin pi is sin 180 degree is 0. So cos pi is minus 1. Likewise, cos 3 pi is minus 1. Cos 5 pi is minus 1. So minus 1. So that becomes minus 1. So minus 1 and minus 1, it again becomes minus 2. So that can be taken outside. That becomes minus 4a by minus jn omega naught t naught. That minus sign and minus sign gets cancelled. Okay, what you get is 4 plus 4a divided by jn omega naught t naught for n is equal to odd. Okay, again I can substitute the same thing, that is if omega naught is equal to t naught, omega naught is equal to 2 pi by t naught. What happens if I substitute that 2 pi by t naught and t naught gets cancelled. In the denominator you will be having jn 2 pi. Okay, that's what. So that 2 pi 2 and the numerator 4 gets cancelled. So then in the numerator 4 gets cancelled, it becomes 2. So and if I take the j from denominator to numerator, that becomes minus j. That is 1 by j is nothing but minus j. So everything substituting, you'll get Cn bar for when n is odd is minus j 2a by n pi. Okay, so I repeat, that is you might have understood, that is for n is odd, the result is plus 4a by jn omega naught by n omega naught t naught. So simply substitute for omega naught as 2 pi by t naught. T naught and t naught will get cancelled, and denominator will be having jn 2 pi, and that denominator 2 and numerator 4 gets cancelled, and numerator it will have, instead of 4 you will have 2, and denominator you will have plus j. That plus j you make it to the numerator, that becomes minus j. So minus j 2a by n pi. So here you can say that that is n is for n is odd, the value for Cn bar is nothing but minus j 2a by n pi, and all even order harmonics are absent, and of course Cn naught is equal to 0. Okay, why Cn naught is equal to 0? That's an even halfway symmetry showing, that is whatever happening in positive half of the time period is happening in the reverse manner. Whatever value in the positive half cycle is it having negative value in the next half. That is a is from 0 to t naught by 2 minus a is from t naught by 2 to t naught. So when you take the average value for a full cycle, of course that will be 0. So C naught is equal to 0. So that is the answer, but we have to make some comparisons. See, I told that we have done that example 4.7 in that material which I have earlier sent earlier, and we have to get the same result here also. Now we have found Cn bar as minus j2a by n pi. Okay, just just see the bottom point of that slide, and we know what is Cn bar. Cn bar in general is an minus jbn by 2. Okay, so here whatever result we have, we don't have any real part, so that means an is also 0. So a naught is already 0, an is equal to 0 here. Now we have only imaginary part, so we compare the imaginary parts, that is 2a by n pi should be equal to bn by 2. So what is bn? Bn is equal to 4a by n pi. This was a result that we got. When we done the example 4.7. Okay, so one more thing I failed to attach to this slide, but I'll send it as a material. That is, using this result you can actually plot the frequency spectrum. That is frequency spectrum in the sense that is you can find the magnitude of Cn bar. See, why is magnitude and phase for Cn bar? I already stated that Cn bar is nothing but a complex number. Complex number will have its own magnitude and phase. So if you find the phase and the magnitude of Cn bar for various values of n, you can plot magnitude spectrum as well as phase spectrum. So if j is attached to any Cn bar, then the angle is 90 degree. If it is minus j, the angle is, or the phase is minus 90 degree. And whatever is the magnitude of Cn bar can be represented for that n value. Okay, I'll just send that material. You can easily understand what is that frequency spectrum. And whenever you're finding the whenever you're finding the Fourier series, it is very important to draw and plot the magnitude as well as phase spectrum, and both are called as frequency spectrum. Okay, so that material also I'll attach to this, and that is where I stop today. And this much portions are there for your first internal. So try to do try to do the problems that I have sent for Fourier series, and everything is very important, and you can expect 1 or 2 problems from this portion also. Thank you.